Hello everyone, welcome to Tech with Shaping Pixel. Today in this video, we are going to cover AI-900 Microsoft Azure AI Fundamentals cheat sheet. If you haven't subscribed to our channel, please subscribe to Tech with Shaping Pixel. Let's start our video. Azure AI Services. Azure AI Services Platform. Integrated Platform. Azure AI Services provides a comprehensive suite of tools and APIs for constructing, deploying, and overseeing AI models. Audience. Designed to cater to developers, data scientists, and business analysts alike, Azure AI delivers solutions tailored to individual requirements. Azure AI Vision. Empowering visual intelligence. Cutting edge capabilities. Under the umbrella of Azure AI Vision, users can leverage advanced computer vision capabilities to dissect images and videos seamlessly. Image tagging. Identify and categorize objects, scenes, and concepts within visual content effortlessly. OCR functionality. Extract printed and handwritten text from images across diverse languages and writing styles. Facial recognition. Develop intelligent applications capable of discerning and authenticating human identity seamlessly. Enhancing content discoverability. Automated image analysis. Azure AI Vision's image analysis component offers automated generation of natural language captions for images. Smart cropping. Employ smart cropping techniques to optimize visual aesthetics. Content classification. Classify images based on content to enrich user experiences and render content more accessible and engaging. Secure user experiences with facial recognition. Authentication. Ensure secure user experiences by enabling seamless authentication, access control, and personalized services. Facilitating text extraction with OCR. Digitization. Instrumental in extracting text from images for the digitization of documents, forms, and handwritten notes. Real-time spatial analysis. Movement monitoring. Empowers users to monitor movements and scrutinize environments in real time. Applications. Invaluable tool for applications spanning surveillance, retail analytics, and smart spaces. Customization options. Tailored models. Offer the flexibility to tailor computer vision models to spec requirements through custom image classification and object detection. Adaptability. Train models with minimal image inputs to adapt classification and detection mechanisms to unique needs. Responsible AI practices. Guidance. Microsoft emphasizes responsible AI practices, providing comprehensive guidance on ethical and accurate utilization of AI capabilities. Adherence. Adhering to responsible AI standards ensures that users achieve optimal outcomes while upholding ethical principles. Azure Content Moderator. Use cases. Social messaging, gaming industry, education sector. Enterprise media, and online platforms. Key features: text analysis, image moderation, video content management, and content safety studio. Language support, wide language coverage, supports over 100 languages, ensuring comprehensive moderation capabilities for global audiences. Specific language expertise, specifically trained in major languages including English, German, Japanese, Spanish, French, Italian, Portuguese, and Chinese, ensuring accurate detection and moderation across diverse linguistic contexts. Transition to Azure AI Content Safety. Advanced features. Azure AI Content Safety represents the evolution of Azure Content Moderator, offering advanced AI capabilities and enhanced performance for a wide range of scenarios. Versatility. Suitable for various applications, including those mentioned above, Azure AI Content Safety provides comprehensive solutions for managing and ensuring the safety of digital content. Computer vision. Computer vision, a captivating domain within AI, enables computers to recognize and comprehend objects and individuals in visual media. It seeks to emulate human capabilities by automating tasks like object recognition, pattern detection, and visual interpretation. Operating at the intersection of various fields, it aims to automate processes akin to human perception. Tasks include recognizing objects, identifying patterns, and interpreting visual data. How it works: data driven learning. Computer vision relies on extensive data sets to learn and generalize effectively. It iteratively analyzes data to identify differences and patterns. Deep learning and convolutional neural networks. Deep learning algorithms empower computers to self educate on visual data context. CNNs decompose images into pixels, assigning labels and predicting visual content. The neural network refines its predictions over time to match real world observations, mimicking human visual perception. Applications: object identification, facial detection and identification, image categorization, medical imaging analysis, public space monitoring, manufacturing quality assurance, and self driving vehicle technology. Challenges: image variability, noise and uncertainty management, scale and perspective recognition, and real time analysis. Natural language processing. NLP represents a distinct domain within the realm of AI, aiming to streamline communication between machines and humans through the use of natural language. Utilizing computational techniques, NLP delves into the analysis and understanding of both textual and verbal communication to derive significant interpretations. Applications: voice activated assistants, emotional analysis, summarization algorithms, entity recognition, interactive chatbots, and language translation tools. Challenges: contextual understanding, expression diversity, interpretation complexity. NLP tasks, speech recognition, converting spoken language into text, a fundamental function for voice control systems. Word sense disambiguation, resolving the correct meaning of a word with multiple interpretations based on its context. Part of speech tagging, identifying the grammatical function of each word within a sentence. Language modeling, predicting the subsequent word in a sentence based on contextual cues to enhance coherence and fluency. Knowledge mining. Knowledge mining is an emerging field within artificial intelligence focused on leveraging intelligent services to rapidly learn from vast data volumes. Its primary aim is to empower organizations with profound insights, enabling easy exploration of information, uncovering hidden patterns, and identifying relationships on a large scale. Components and capabilities. Semantic search. Azure provides semantic search functionalities, discerning user intent and contextually ranking search results for relevance. This allows users to navigate content more efficiently and access contextually pertinent information. Content ingestion. Knowledge mining enables content ingestion from diverse sources such as Azure Blob Storage, Azure Table Storage, Azure SQL Database, and Azure Cosmos DB. Dedicated connectors facilitate data extraction from hundreds of third party sources, streamlining the process. Content enrichment. Utilizing AI capabilities, knowledge mining extracts insights, discovers patterns, and enhances understanding of content. Techniques include text extraction from file formats like PDF, Microsoft Word, PowerPoint, and CSV, augmenting data comprehensiveness. Exploration and discovery. Once content is indexed, users can explore it through various interfaces, including search interfaces, bots, existing business applications, and data visualizations. This facilitates seamless exploration and discovery of relevant information. Use cases: content research, auditing, risk and compliance management, customer support and feedback analysis, and business process management. Azure services for knowledge mining. Azure AI Search, the sole cloud search service embedded with AI capabilities, facilitating the identification and exploration of relevant content. Azure AI Services utilizes cognitive capabilities to comprehend diverse content types, aiding in information extraction and analysis. Azure Machine Learning empowers the application of custom machine learning models as skills tailored to specific requirements, enhancing data processing and insights generation. Azure AI Bot Service enables the design of interactive experiences that allow users to extract information seamlessly through bot interfaces enhancing user engagement and information retrieval efficiency. Azure AI Document Intelligence, Automated Extraction. Leveraging AI and OCR technology, Azure AI Document Intelligence automates text and structure extraction from documents, ensuring swift data processing. Streamlined information extraction. The primary objective is to streamline information extraction, effectively converting documents into actionable data for improved decision making. Key features: automated extraction, focus optimization, pre built and custom models. Deployment flexibility, cloud or edge deployment, and enhanced security. Generative AI. Artificial intelligence replicates human behavior via machine learning algorithms, enabling autonomous task execution without explicit instructions. Generative AI, a subset of AI, specializes in generating original content based on encountered context, exemplified by Microsoft Copilot, enhancing web browsing experiences. Generative AI applications accept natural language inputs and produce relevant responses across various formats, employing sophisticated algorithms for contextual understanding. Features: natural language processing enables accurate comprehension and interpretation of human language inputs. Contextual understanding understands conversational context to generate coherent and relevant responses. Content generation capable of producing diverse content types like text, images, and code snippets. Adaptability continuously learns from interactions and feedback, improving over time. Use cases: conversational assistants, creative content generation, code generation, personalized recommendations, and content creation and automation. Responsible AI. Responsible AI, also known as ethical AI, places a strong emphasis on ensuring that AI development and deployment aligns with human values and respects individual rights. As AI becomes more prevalent, it becomes increasingly important to address unintended biases and potential harm they may arise from its use. Features: equity and inclusion, reliability and safety, privacy and security, transparency, accessibility, and accountability. Machine learning fairness. Machine learning fairness pertains to ensuring AI models avoid discriminatory behavior or bias against particular demographic groups. Objective: the goal is to develop models that treat all individuals equitably, irrespective of their demographic attributes like gender, race, or age. Types of AI caused harms. Harm of allocation. AI systems allocate or withhold opportunities, resources, information for specific group. Harm of quality of service. AI systems exhibit performance disparities across different groups. Group fairness approach. Identifying at-risk groups. Quantifying fairness. Responsible AI dashboard. Purpose. The dashboard evaluates model fairness during both training and deployment phases. Disparity assessment. It quantifies disparities across subgroups based sensitive features. FairLearn open source package. Functionality. FairLearn aids in assessing impact and devising mitigation strategies. Flexibility. It allows for trade offs tailored to specific scenarios. Trade offs and human decision making. Complexity. Fairness is a socio technical challenge with quantitative metrics unable to capture all fairness aspects. Human judgment. Humans must navigate trade offs based on context and values in addressing fairness concerns. AI shared responsibility model. Division of responsibility. Shared responsibility model. When implementing AI capabilities, it's crucial to understand the shared responsibility model, which outlines the tasks handled by the AI platform or application provider versus those managed by the user. Variation by service type. Responsibilities differ based on whether the AI integration uses software as a service, platform as a service, or infrastructure as a service. AI layer overview. AI platform. Functionality. Supplies AI capabilities to applications. Responsibilities. Includes constructing and securing the infrastructure for the AI model, managing training data, and configuring model parameters. Access. Typically accessed via APIs. AI application. Functionality. Utilizes AI capabilities to deliver services or interfaces to users. Complexity. Components can range from simple to highly sophisticated depending on the application. AI security considerations. Platform protection. Safeguard the AI platform from malicious inputs. Safety systems. Implement measures to filter harmful instructions sent to the model and prevent the generation and return of harmful content. Microsoft's commitment. Security focus. Microsoft prioritizes security and provides built in safety systems for both platform as a service and software as a service AI offerings. Platform as a service protects against harmful inputs and outputs. Software as a service ensures safety during AI interactions. Transparency note for Azure AI Studio safety evaluations. What is a transparency note? Purpose. Microsoft's transparency notes aim to help users understand AI technology, including how it operates, decisions that system owners can make to influence performance and behavior, and the importance of considering the entire system. Content. These notes offer insights into AI models, including their capabilities, limitations, and potential risks. Azure AI Studio Safety Evaluations. Purpose. Objective. These evaluations enable users to assess the outputs of their generative AI applications for potential textual content risks. Content risks evaluated: hateful and unfair content, sexual content, violent content, self harm related content, jailbreak vulnerability. How it works. Evaluation method. Users evaluate their generative AI applications outputs using specific prompts. AI assisted simulator. The simulator stimulates adversarial interactions to generate a test dataset with the application's responses. Groundedness evaluation provides insights into ungrounded parts of generative responses, helping to identify and correct issues. Responsible innovation. Microsoft's commitment. Azure AI Studio safety evaluations demonstrate Microsoft's dedication to responsible AI. Risk mitigation. By assessing and mitigating risks, developers can create AI systems that adhere to ethical and safety standards. Azure Machine Learning. Azure Machine Learning is a cloud based service designed to support the large scale development, deployment, and management of machine learning models. It provides a wide range of tools and services tailored for data scientists, developers, and business analysts. Facilitates the creation and management of complete end to end machine learning workflow. Key features and capabilities. Model training and experimentation. Construct and train machine learning models using a diverse selection of algorithms and frameworks. Investigate different hyperparameters to assess and enhance model effectiveness. Automated ML. Streamline the process of model selection and hyperparameter tuning with automated machine learning functionalities. Azure ML independently evaluates numerous algorithms and configurations, pinpoint the most effective model. Model deployment and management. Deploy machine learning models as either web services or within web containers. Monitor model performance, implement necessary modifications, and efficient manage versioning. Integration with Azure services. Seamlessly merge with various Azure services such as Azure Databricks, Azure Data Factory, and Azure Synapse Analytics. Utilize data pipelines and coordination tools to enable through machine learning workflow. Use cases and scenarios. Predictive analytics, computer vision and natural language processing, anomaly detection, and recommendation systems. Security and compliance, data and model security. Azure ML implements strong security protocols to safeguard both data and train models. Guarantee adherence to privacy regulations and industry standards to maintain compliance. Machine learning algorithms. Machine learning algorithms are computational models that enable computers to identify patterns and forecast outcomes from data without explicit programming. These algorithms serve as the foundation of contemporary artificial intelligence and are applied across various domains such as image recognition, natural language processing, recommendation systems, fraud detection, and autonomous vehicles. Supervised learning algorithms. In supervised learning, models undergo training using labeled datasets to understand the relationship between input data and output labels. This enables the model to predict or classify new unseen data. Linear regression, a straightforward method commonly used for tasks involving regression. Logistic regression, employed for tasks requiring classification with associated probabilities. Support vector machines, highly adaptable and robust for both classification and regression tasks. Decision trees, models structured in a hierarchical manner for interpretability. Random forest, an ensemble technique consisting of multiple decision trees. Naive Bayes classifier, a probabilistic algorithm known for its computational efficiency. K nearest neighbors, an unsupervised and iterative approach utilized for both classification and regression problems. Unsupervised learning algorithms. In unsupervised learning, algorithms operate on data without predefined labels. The objective is to unveil inherent patterns or cluster similar data points. Examples: clustering organizes data into groups based on similarity. Dimensionality reduction condenses data while retaining crucial information. Association rule mining uncovers interesting connections among variables. Ensemble learning algorithms. Ensemble methods amalgamate multiple models to enhance overall performance. Examples: random forest merges several decision trees. Boosting sequentially improves weak models and aggregates their predictions. Generative models. These models discern the underlying probability distribution of the data. Examples: naive Bayes applied in text classification and spam detection. Gaussian processes utilized for regression and estimating uncertainty. Time series forecasting algorithms. These algorithms prognosticate future values based on historical data. Examples: ARIMA, autoregressive integrated moving average, handles time series data effectively. Exponential smoothing captures trends and seasonal variations. Deep learning algorithms. These neural network architectures acquire intricate representations from data. Examples: convolutional neural networks, specialized in image recognition tasks. Recurrent neural networks, tailored for sequential data processing like natural language tasks. Linear regression. Linear regression is a statistical method used to establish the connection between independent variables, often referred to as features, and a numeric outcome, known as the dependent variable. It's widely used in both statistics and machine learning for basic predictive tasks. Despite its simplicity, linear regression is effective even on datasets with few data points and straightforward relationships. Fundamental concepts. Simple regression. In simple regression, there's one independent variable that influences a dependent variable. Azure Machine Learning's linear regression component accommodates this scenario. Multiple linear regression. Multiple linear regression entails two or more independent variables affecting a single dependent variable. Situations where numerous inputs forecast a numerical outcome are termed as multivariate linear regression. Error and fit measurement methods. The linear regression component supports two methods. Ordinary least squares aim to minimize the sum of squared differences between observed and predicted targets. Gradient descent, an iterative strategy for reducing error during model training. How to use linear regression component. Model initialization. Access the Initialize Model section within Azure Machine Learning Designer. Navigate to regression by expanding the options. Drag the linear regression model component into your pipeline. Configuring properties. Within the properties pane, opt for the ordinary least squares method as the solution approach. How to select algorithms for Azure Machine Learning. When choosing algorithms for Azure Machine Learning, it's crucial to take into account your specific data science situation and project needs. Here are some important aspects to consider. Business inquiry and objective. Characteristics of data. Model complexity and interpretation. Accuracy and efficiency. Assumptions and constraints. And experimentation and comparative analysis. Create an Azure ML compute cluster. A compute cluster in Azure Machine Learning is a centrally managed setup that simplifies the creation of either a single or multiple node computing environment. It facilitates the distribution of tasks like training models or performing batch inference across a collection of CPU or GPU based compute nodes hosted in the cloud. Here's a guide on how to set up and oversee one. Prerequisites. Access to an Azure Machine Learning workspace. Create one via Azure Portal or Azure CLI if not available. Installation of Azure CLI extension for machine learning service. Execute command. Steps to create a compute cluster. Initialize your workspace in Python. Connect to your Azure ML workspace using the Azure Machine Learning Python SDK in your Python script. Replace subscription ID, resource group, and AML workspace name with your actual values. Example code snippet. Create the compute cluster. Utilize the ML client handler to create a compute cluster. Specify the desired configuration such as VM size and number of nodes. Example code snippet. Use the compute cluster. Once created, utilize the compute cluster as a target for training or inference jobs in your Azure Machine Learning workspace. Deep learning. Deep learning, as employed in Microsoft Azure, refers to a form of machine learning categorized by the utilization of artificial neural networks. These networks empower digital systems to glean insights and make determinations using unstructured and unlabeled data. Unlike traditional machine learning, which relies on structured data, deep learning enables AI systems to learn from experiences, identify patterns, offer recommendations, and evolve autonomously. How deep learning functions? Deep learning operates through intricate neural network architectures comprising multiple layers. The cloud or cluster based deployment of high performance GPUs is pivotal for achieving remarkable accuracy in tasks such as text, speech, and image recognition. The effective training of deep learning models necessitates substantial volumes of labeled data. Significance of deep learning. Data scientists and developers harness deep learning for analyzing vast and intricate datasets, executing intricate and nonlinear operations, delivering prompt and precise responses to text, voice, or image inputs surpassing human capabilities. Deep learning finds practical utility across diverse sectors such as autonomous vehicles, smart home technology, and healthcare. Frameworks and enhancements. Developers employ deep learning frameworks like TensorFlow or PyTorch to construct sophisticated machine learning models. Accelerators like ONNX runtime enhance the performance of these frameworks, expediting both training and inference processes. Create and explore datasets with labels. What are datasets with labels? Developers employ deep learning frameworks like TensorFlow or PyTorch to construct sophisticated machine learning models. Accelerators like ONNX runtime enhance the performance of these frameworks, expediting both training and inference processes. Prerequisites. Azure subscription, Azure Machine Learning SDK for Python, Machine Learning Workspace, access to an Azure Machine Learning data labeling project, export data labels, explore label datasets with Pandas data frame, create a label dataset using Azure Machine Learning. What is a label dataset? A label dataset consists of data samples along with corresponding labels or annotations. These labels provide ground truth information about the data, allowing machine learning models to learn patterns and make predictions. Prerequisites: Azure subscription and Azure Machine Learning Workspace. Steps to create a label dataset. Data labeling project. Create a data labeling project in Azure Machine Learning. Choose the type of labeling task. Upload data. Upload your data samples to the labeling project. Assign labels or annotations to each sample based on the task requirements. Review and export labels. Review the label data to ensure accuracy. Export the label data as an Azure Machine Learning dataset. Explore the labeled dataset. Load the labeled dataset into your machine learning pipeline. Use it for training, validation, or testing your machine learning models. Data splits and cross validation in automated machine. Data splits. Training data. The training data is used to train the machine learning model. It contains labeled examples. Validation data. The validation data is used to tune hyperparameters and evaluate model performance during training. It helps prevent overfitting by assessing how well the model generalizes to unseen data. Test data. The test data is used to evaluate the final model's performance after training. It provides an unbiased estimate of the model's accuracy on new unseen data. Cross validation. K-fold cross validation. Partition the dataset into K equally sized groups. Train the model K times using K1 groups for training each time and the remaining group for validation. Calculate the average performance over all K groups. Stratified K-fold cross validation. Ensure each fold reflects the overall distribution of target labels, especially useful for datasets with imbalanced classes. Leave one out cross validation. Use each individual data point once as the validation set, with the rest used for training. Best suited for smaller datasets. Shuffle split cross validation. Randomly split the data into training and validation sets multiple times. Ideal for large datasets. Automated machine learning. What is automated ML? Auto ML, known as automated machine learning, simplifies the process of selecting the optimal machine learning algorithms and parameters for a given dataset. It enhances productivity and efficiency in creating models while maintaining quality standards. Auto ML in Azure Machine Learning. Azure Machine Learning's Auto ML creates multiple pipelines simultaneously during training, experimenting with diverse algorithms and parameters. Through iterative testing, it explores various algorithm feature combinations to optimize for specific metrics until predefined criteria are met. Key steps in AutoML process: identifying the problem, experience selection, specifying data source, configuring AutoML, submitting training job, and reviewing results. When to use AutoML? AutoML is suitable for various tasks including classification, regression, forecasting, computer vision, and NLP. It's particularly valuable for rapid prototyping, exploring different algorithms and feature engineering techniques, and minimizing manual effort in model selection and tuning. Benefits of AutoML: efficiency, accessibility, scalability, and quality. Azure's automated machine learning capabilities. Azure's automated machine learning simplifies model development by intelligently selecting and training models without manual intervention. It enhances scalability, efficiency, and productivity while maintaining quality standards. Key features: automated model selection, increased accessibility, simplified workflow, and enhanced model quality. Enhanced features: no code web interface, model transparency, time series forecasting, and ONNX models. .NET integration, Power BI integration, and SQL Server and Spark integration. Benefits: intelligent stopping, subsampling strategy, pre-processing optimization, XGBoost support, and enhanced dataset support. Machine learning solutions for data scientists. Machine learning on Azure. Leverage tools for data scientists and engineers to build and deploy scalable machine learning solutions. Features: develop models on your terms, build responsibly, and confident deployment. Using machine learning for mission critical applications. Scaling training jobs, model deployment, and inferencing. Understanding MLOps, securing machine learning environment. Hybrid and multi-cloud machine learning, and open and interoperable machine learning. MLOps, machine learning model management. Understanding MLOps. MLOps comprises best practices for deploying and managing machine learning models in production efficiently, drawing inspiration from DevOps principles. It ensures collaboration and communication between software developers and IT professionals. Need for MLOps. With machine learning models increasingly integrated into business operations, a systematic approach to their management becomes essential. MLOps automates the machine learning lifecycle, fosters team collaboration, and ensures reliable model deployment. Key components of MLOps: version control, continuous integration and delivery, monitoring and operations, governance and compliance. MLOps lifecycle stages: development, testing, deployment, monitoring, and maintenance. Benefits of MLOps: efficiency, scalability, reproducibility, and quality. Azure AI Vision. Azure AI Vision integrates functionalities that were formerly part of cognitive services and Azure Applied AI services. It offers a range of tools and services designed to help applications interpret and analyze visual data, effectively allowing them to see and comprehend visual information. Services offered by Azure AI Vision: text extraction, image feature analysis, face recognition and analysis, and video content analysis. Azure AI Vision for digital asset management. Azure AI Vision optimizes digital asset management by effectively organizing, storing, and retrieving rich media assets while handling digital rights and permissions. It can classify and identify images based on visible features such as logos, faces, objects, and colors. Additionally, it can automatically generate captions for images, enhancing their searchability. Azure AI Vision with OCR and AI. Azure AI Vision is a comprehensive service offering advanced computer vision capabilities, enabling applications to analyze images, read text, and detect faces using pre built models. The service integrates OCR and AI, providing developers with a broad range of vision features, even if they lack machine learning expertise. Key features of Azure AI Vision: image analysis, spatial analysis, OCR, and facial recognition. Enhancing content discoverability with image analysis. Real time video streaming with spatial analysis. Reading text from images with OCR. Verifying identities with facial recognition. Customizing computer vision models. And applying AI responsibly. Azure AI Face Service provides AI algorithms for detecting, recognizing, and analyzing human faces in images. Useful for scenarios like identification, touchless access control, and privacy related face blurring. Accessing the face service. Used through a client library SDK. Directly call the REST API. Use cases: identity verification, touchless access control, face detection and analysis, liveness detection, verification, group, Identification, find similar input requirements. Image classification on Azure. By leveraging Azure services like the Computer Vision API and Azure Functions, companies can avoid managing individual servers, cut costs, and benefit from Microsoft's expertise in image processing through Azure AI services. This example scenario focuses on an image processing application. For other AI requirements, explore the comprehensive range of Azure AI services. Workflow. The scenario outlines the backend processes for a web or mobile application. The data flow follows these steps. Retail industry, fashion website, gaming industry, game screenshot classification, finance and insurance industry, insurance claims processing, object detection, Azure AI Vision. Azure's object detection uses deep learning to identify objects and images, marking them with bounding boxes. It then classifies these objects and integrates seamlessly into applications through APIs. This functionality enables tasks like image tagging, content moderation, and inventory management, driving innovation and enhancing user experiences. Detection constraints. Small objects, typically less than 5% of the image, may not be accurately detected. Objects arranged closely together, such as in stacks or clusters, might pose challenges for detection. Brand or product name differentiation is not supported, such as distinguishing between various soda types on a store shelf. Utilizing the API. Access the API through a native SDK or via REST calls. Specify the inclusion of objects in the visual features query parameter to enable object detection. Upon receiving the full JSON response, extract and interpret the object section to access relevant information. Optical character recognition. Azure AI services. Optical character recognition, or OCR, uses machine learning to extract text from images like posters, street signs, product labels, and various documents. It organizes the extracted text into words, lines, and paragraphs, providing digital access and reducing the need for manual data entry. Microsoft's Read OCR engine, supporting multiple languages, utilizes advanced machine learning models for multilingual support, extracts printed and handwritten text, accommodating diverse writing styles and mixed languages. Deployment flexibility, available as both a cloud service and an on premises container, ensuring deployment flexibility. Latest update, introducing Read as a synchronous API, enhances OCR assisted user experiences with performance improvements, catering specifically to single image only scenarios. Features, integration into platforms, key capabilities, support for mixed languages, on premises deployment, compatibility and integration. face detection, attributes, and input data. Face detection. Face detection refers to the identification of human faces within an image. This process involves locating the positions of faces and can optionally include retrieving various face related data. The Detect API is utilized to perform face detection tasks on an image. Face attribute data. Face attribute data encompasses different characteristics or features associated with detected faces. These attributes may include details such as age, gender, emotion, facial landmarks, and facial hair. By using the Detect API, users can access and retrieve face attribute data along with the detected faces in an image. Face attributes in face detection: face rectangle, face ID, and face landmarks. Fundamentals of generative AI training. Artificial intelligence mimics human behavior using machine learning, interacts with the environment to perform tasks without detailed instructions. Generative AI, a specialized branch of AI that creates new content. It is commonly found in chat applications such as Microsoft Copilot, which aids in more effective web browsing, processes natural language inputs, and produces suitable responses in various forms, including text, images, and code. Language models. Generative AI applications leverage language models, which are specialized machine learning models designed for natural language processing tasks, such as assessing sentiment or classifying text, summarizing content, evaluating semantic similarity across different text sources, and creating new text. Although the mathematical concepts behind these language models are intricate, having a basic grasp of their architecture can provide a conceptual understanding of their functionality. How transformer model work? Transformer architecture, training with large text corpora, predictive text sequences, and human-like language generation. Transformer models, large language models, and small language models. Azure AI model resources and catalog. Azure OpenAI service provides access to foundation models like GPT and DALI, offers secure and scalable hosting on Azure, enables developers to fine-tune models with custom training data. Model catalog in Azure, curated repository of pre-trained AI models, accessible to data scientists and developers, includes latest open source models from various partners, enables easy integration of advanced AI capabilities into projects. Generative AI in Azure Machine Learning. Generative AI and its features. Simplified development, robust infrastructure, text generation, conversational interaction, comprehensive environment, efficient deployment, scalability and performance, and enhanced user experience. Integrate model catalog, foundation model catalog, prompt flow, open source framework integration, Azure AI infrastructure, content safety, and model monitoring. Content creation and design, accelerated automation, personalized marketing, chatbots and virtual assistants, product and service innovation, language translation and NLP, fraud detection and cybersecurity, predictive analytics and forecasting, creative writing and content generation, and medical research and diagnosis. Responsible AI. Responsible AI implementation. Azure AI facilitates the development, utilization, and governance of AI solutions in a responsible manner, ensuring compliance with ethical standards and regulations. Responsible AI features scalability and confidence, built in governance tools, industry leading technologies, integration of responsible AI, and trusted foundation. Principles of responsible AI. Microsoft's responsible AI commitment. MLOps streamlining ML workflows. Model interpretability, ensuring transparency. Overview of responsible AI practices for Azure OpenAI. Responsible AI implementation framework. Identify potential harms. Measure harm occurrences. Mitigate identified harms and operational readiness. Responsible AI practices for Azure OpenAI. Identifying AI harms. Systematic measurement of AI harms. Mitigating AI harms. Model level, safety system level, application level, and positioning level. Contrast between Azure OpenAI Service and OpenAI. Azure OpenAI Service. Azure OpenAI Service for advanced language and image processing tasks. Resources. Azure OpenAI Setup. Create a resource or instance in your Azure subscription. Refer to Azure's resource management design for details. Deployments. Model deployment. Create an Azure OpenAI resource. Deploy a model using deployment APIs before making API calls. Prompt engineering. Prompt-based models. Models respond to text prompts with text completions. Effective prompt crafting is crucial. Example models: GPT-3, GPT 3.5, and GPT-4. Models. Model varieties. DAL-E generates images from text prompts. Whisper transcribes and translates speech to text. Text to speech synthesizes speech from text. Azure OpenAI for code generation and development tasks. Azure OpenAI Service leverages large language models for content generation, including programming code. Functionality allows developers to generate and improve existing code across various programming languages, enhancing efficiency and understanding. Utilizing Azure OpenAI to generate code and assist with development tasks. Quick start. Generate images with Azure OpenAI Service. Navigate to Azure OpenAI Studio and log in using the credentials linked to your Azure OpenAI resource. During or after the login process, choose the correct directory, Azure subscription, and Azure OpenAI resource. Begin exploring Azure OpenAI capabilities through a no-code approach with the DALI Playground. Additionally, in the DALI Playground, you can POTIS NLP. Natural language processing enables applications to interact with users by seeing, hearing, speaking, and understanding them. Microsoft Azure simplifies the creation of NLP supported applications through text analytics, translation, and language understanding services. NLP has various applications, including sentiment analysis, language detection, document categorization, topic detection, and key phrase extraction. NLP workload scenarios and common features. Customized NLP frameworks with Apache Spark. Apache Spark boosts big data analytics with efficient in-memory processing. Platforms like Azure Synapse Analytics, Azure HD Insight, and Azure Databricks utilize Spark's capabilities. Spark NLP is ideal for customized NLP tasks processing large text datasets. This open source library supports Python, Java, and Scala, offering full NLP functionalities similar to SPACY, NLTK, Stanford Core NLP, and OpenNLP. Key features of Spark NLP include spell checking, sentiment analysis, and document classification. Spark NLP excels with superior accuracy, speed, and scalability compared to earlier solutions. Key phrase extraction in Azure AI language. Key phrase extraction is a feature provided by Azure AI language which encompasses a suite of machine learning and AI algorithms available in the cloud for creating intelligent applications that process written language. This feature allows you to rapidly identify the central ideas and concepts within the text. Methods to use key phrase extraction. Language Studio platform. Accessible online without needing an Azure account. Allows experimentation with NLP features using provided text examples or your own uploaded data. Users can visit the Language Studio website and follow a quick start guide for detailed instructions. REST API or Client Library enables developers to integrate key phrase extraction directly into their applications. Offers a REST API for making HTTP requests and a client library in various programming languages. Developers can utilize the REST API by sending HTTP requests to specific endpoints or use the client library's pre-built methods in their preferred programming language. Docker container deployment allows for running the key phrase extraction service locally on premises infrastructure via Docker containers. Provides greater control over data and operations suitable for environments with strict compliance and security requirements. Users can download and run the Docker container image, beneficial for organizations with specific regulatory or operational constraints. Each of these options caters to different use cases and technical requirements, providing flexibility in how you deploy and use the key phrase extraction feature. Summary of the typical workflow for using this feature in Azure AI language. Named entity recognition in Azure AI language. Named entity recognition is a feature available in Azure AI language which compromises machine learning and AI algorithms hosted in the cloud for building intelligent applications involving written language. Methods to use named entity recognition. Two methods are available for utilizing named entity recognition: Language Studio platform and REST API or client library. Use cases: enhance search functionalities and indexing, customer insights and analysis, and automate operational workflows. Sentiment analysis and opinion mining. Sentiment analysis and opinion mining are features within the language service a cloud based suite of AI algorithms for analyzing written language. They help discern public sentiments about brands or topics by detecting positive or negative cues in text and associating them with specific elements. Compatible with multiple languages. Sentiment analysis. This feature assigns sentiment labels like negative, neutral, and positive based on the highest confidence score identified by the service at both sentence and document levels. Additionally, it provides confidence scores ranging from 0 to 1 for each document and its sentences for positive, neutral, and negative sentiments. Opinion mining. A subset of sentiment analysis, opinion mining, also known as aspect based sentiment analysis in NLP, offers detailed insights into opinions related to specific words, such as attributes of products or services within the text. Methods to use sentiment analysis: Language Studio Platform, REST API or Client Library, Azure SDK, and Docker Container Deployment. Azure AI Language, Azure AI Services. Azure AI Language is a cloud service offering natural language processing capabilities for text analysis and comprehension. It aids in developing intelligent applications through the web based Language Studio, REST APIs, and client libraries. This service consolidates several former Azure AI services, including Text Analytics, Q&A Maker, and Lewis. Features. The language service also offers several new features which can be either pre-configured. These features use AI models that are not customizable. You simply send your data and use the features output in your applications. Or customizable. These features allow you to train an AI model using our tools to specifically fit your data. Pre-configured features. Named entity recognition, personally identifying information and health information detection, language detection, sentiment analysis and opinion mining, summarization, key phrase extraction, entity linking, text analytics for health, and question answering. Customizable features: custom text classification, custom named entity recognition, conversational language understanding, orchestration workflow, and custom text analytics for health. Use cases: speech service, Azure AI services, speech to text and text to speech functionalities. The speech service offers both speech to text and text to speech functionalities via a speech resource. You can accurately convert spoken words into text, generate natural sounding voices from text, translate spoken audio, and recognize individual speakers in conversations. Customization and model development. You can create custom voices, expand your base vocabulary with specific words, or develop personalized models. The service runs seamlessly in the cloud or on the edge in containers. Easy integration. Enabling speech capabilities in your applications, tools, and devices is straightforward with the Speech CLI, Speech SDK, Speech Studio, or REST APIs. Deployment options for Azure AI Speech: cloud deployment, on premises deployment using containers, sovereign cloud deployment, common use cases for speech, captioning, audio content creation, and call centers. Language learning and voice assistants. Microsoft applications. Microsoft uses speech for various purposes, including captioning in Teams, dictation in Office 365, and the read aloud feature in the Microsoft Edge browser. Document translation. Azure AI services. Document translation is a feature offered by the Azure AI Translator service, allowing cloud based machine translation of various documents. It supports translation of multiple and intricate documents across all available languages and dialects while maintaining the original document structure and data format intact. Asynchronous batch document translation and synchronous document translation. Synchronous document translation. Utilize synchronous translation processing by including the document within the HTTP request body and retrieving the translated document directly in the HTTP response. Features: translate individual page documents, maintain original document formatting, personalized translation, customized glossaries, and single language translation. Automatic language detection and leverage customized glossaries. Azure AI language capabilities. What is AI language? Azure AI language is a managed service tailored for crafting applications that process natural language. It empowers users to recognize key terms, assess sentiment, condense text, and construct conversational interfaces. With Azure AI language, you can annotate, train, assess, and implement adaptable AI models without extensive knowledge of machine learning. Use cases: recognize core concepts, comprehend information at a glance, and analyze customer sentiment. Azure AI speech capabilities. What is AI speech? A managed service provides cutting edge speech capabilities, including speech to text, text to speech, speech translation, and speaker recognition. Features: exceptional quality, customization options, deployment flexibility, compliance and security. Use cases: transcribe speech, swiftly and accurately convert audio into text across more than 100 languages and variations. Text to speech: enable your applications and services to speak naturally using text to speech functionality. Speech translation: translate spoken audio in real time from over 30 languages. Speaker recognition: verify individuals' identities or identify speakers within meetings and other settings. Custom keyword activation: personalize your brand's presence by establishing custom keywords for IoT devices and voice enabled assistants. Voice command integration: implement hands free voice commands to facilitate touchless interactions and improve safety. Thank you for watching this video, and don't forget to subscribe to Tech with Shaping Pixel.